Welcome to the 11th quarterly report detailing the progress made by NASA's Ares projects on America's next launch vehicle. Last quarter, the project reported on wind tunnel testing, small solid rocket motors, and J2X power pack disassembly. Work from last quarter continued with upper stage structural testing and manufacture of the Ares 1X roll control system. A 1% scale model of the Ares 1 vehicle was tested to gain more data about the buffeting forces affecting the vehicle during flight. The Ares team has conducted over 7,000 hours of wind tunnel testing. This allows engineers to verify the vehicle's design and confirm that it can withstand aerodynamic forces similar to those it will encounter in flight. Testing is also underway on the various instruments that will be installed on the Ares 1X test vehicle for its flight later this year. This 5-hole air probe will be mounted on the very tip of the vehicle. The probe will collect data on static and dynamic air pressure during the rocket's ascent, which will help determine the final design of the Ares 1 launch abort system. The Ares 1 first stage team achieved a major milestone with the completion of the first demonstration motor called DM1. Using new tools, new liner materials, and new procedures developed over the past 3 years of Ares design work, the team poured live propellant for all 5 segments last quarter. The segments are cast in a vacuum to eliminate trapped air and voids in the propellant. Each segment has an inhibitor at one end, which serves as a wall between one segment and the next. DM1 is the first 5-segment solid rocket motor constructed to Ares specifications. Once the live propellant has finished curing, the segments will be inspected, assembled, and prepared for a live fire test later this year. The team at ATK are also readying final flight hardware for the Ares 1X. The forward segment was recently moved to a vertical position to install the igniter that will start the solid rocket motor. The diagonal pattern of lines on the booster will allow ground crews to measure the vehicle's rotation during flight. While similar in function to the shuttle avionics system, the Ares first stage will use entirely new state-of-the-art electronics. A total of 6 new line replaceable units, or LRUs, will interface with the upper stage, communicate with ground operations, record flight telemetry and environmental data, and command first stage functions such as recovery and thrust vector control. The upper stage team has completed structural buckling tests on a series of subscale aluminum lithium panels. These tests characterized the behavior of several candidate panel designs when subjected to compression. The test apparatus is a modification of an existing fixture previously used for testing shuttle external tank panels. The first 2 Y-rings for the upper stage liquid hydrogen tank were delivered in November 2008 and January 2009. These rings will serve as the interface between the hydrogen tank barrel section and the tank dome. 2 full-scale common bulkhead domes were delivered in January 2009 as well. These domes were originally spun and tested by Spincraft. These domes will be used for the common bulkhead manufacturing demonstration article. Welding on this test article is scheduled to begin in July 2009 with completion in July 2010. Upper stage conducted water flow testing on the series redundant thruster valve, which will be used to control the flow of hydrazine to the roll control system. The tests verified the valve's performance characteristics and provided data to support ongoing roll control hot fire testing. The Ares team also conducted a hot fire test sequence of a prototype roll control thruster this quarter. The hydrazine thruster matched predictions in over 800 pulses, consuming 1,200 pounds of propellant. This demonstrated that the thruster has a live capability of over 4 times the required flight duration. The final avionics control units for Ares 1X were assembled and tested this quarter. Because of the extremely high-quality standards, many assemblies were built by hand, including control circuits and wiring harnesses. Automated testing ensures consistent results and quality. The upper stage avionics box, which will control most of the critical functions of the rocket, went through thermal and vacuum testing to simulate its operating environment and test its durability. Roll control panels for the Ares 1X test vehicle were assembled and tested this quarter. The panels were fitted with thrusters, pressurization tanks, sensors, and wiring. The assembled panels were wrapped in plastic in a clean room to reduce contamination of the system and shipped for final assembly at Kennedy Space Center. The J2X engine will use a gas generator which burns a small amount of the engine's propellant to create hot gas that drives the engine's fuel pumps. The Workhorse gas generator test series uses a heavy-duty version of the hardware that can survive an extended test program, while the actual flight hardware will be expendable. The second series of Workhorse tests began in mid-January 2009. These tests will determine any link between the liquid oxygen systems and injector stability, as well as measure characteristics of the engine turbine. Work continues on the new test stand A3, which will be used to simulate altitude conditions for the J2X during full-scale engine testing. The test stand will use diffusers to inject steam around the engine enclosure, which will lower atmospheric pressure and simulate high altitudes. The massive steel structural beams are being assembled now, as well as docks, for delivery of liquid hydrogen and liquid oxygen. When completed, the test stand will be over 300 feet tall. Join us again next quarter for further developments on the first stage parachute systems, J2X engine testing, and the fabrication of upper stage components at Marshall. If you would like more information about Ares plans and progress, please visit us on the web at nasa.gov/Ares.